So the power rule says the powers go down by one whole. One whole. So whatever it was before, it gets subtracted by 1. That old power then comes to the front and multiplies. Right? Then comes to the front and multiplies. Kind of like down here on the last one. The 4 comes to the front, multiplies, make 12. So let me give you an example. You don't have to write this down, but let me give you an example. Let's do one to see if you can do it. What would that last guy become? 50x to the 4th. Yep, that's what it would become. That's the power rule. That's the biggest rule we're going to use. We use that almost every time we want to find a derivative. Almost every time we want to find a derivative, we're going to use the power rule at least once. That's the biggest tool that we have in our bag of tools to find the derivative. Now, if I was to give you this guy and ask you to find the limit using the limit as x or h approaches 0 for f of x plus h and f minus f of x, that would have taken you probably about 5 to 10 minutes, right? How long did it take us to do using the power rule? Yeah, that's it, right? So the problems are going to go a lot faster now, which is what we want, right? But the limit definition is still important. It's still important because it'll pop up on multiple choice. But for the most part, you're going to use what's called the power rule. Okay, so let's go to example number 1. Find the derivative for each. So we got to find f prime. So what did we say we do with the power? Bring it to the front, multiply it times the coefficient that's already there. So what's the coefficient that was already there? 1, right? X, and then the power goes down by 1. Then we multiply 5 times 1, and it becomes 5x to the 4th. So the derivative is 5x to the 4th. Letter B, we have a power, but I also have a root. What do I do? I can change it to a power, right? What power is that without a root? Close. 2/3, yeah, it's to the 2/3 power, right? So your first step is if it doesn't have a power, give it a power. I don't want roots. Roots I can't use, but powers I can. So I'd rather see this guy as x to the 2/3. Okay, so let me find its derivative. So the power rule says the old power moved to the front. Okay, so 2/3 moves to the front. That multiplies times the old coefficient. What was the old coefficient? 1, right? So multiply that times 1. And then what happens to the old power? It gets subtracted by 1 whole. Yeah, 1 whole. So it's 2/3 minus 1 whole. What is 2/3 minus 1 whole? Negative 1/3. So this guy is 2/3 x to the negative 1/3 power. Let me clean it up a little bit. What do negative powers mean? Down to the bottom, right? Down to the bottom. Okay, so let me see. 2 is on top. So that means x is going to go down here, right? Because it's negative power. And what does 1/3 power mean? So negative means move to the bottom. The third root, yeah, the third root. Yeah, with the third root. It's not a 2 because there's no 2, so it's a little 3. Exactly. It's the third root. So see if I can write it a little better. The third root of x. Because on a multiple choice, so technically this is a right answer. Technically, this guy right here is correct. And I'd give you credit for that because it's correct. But here's the thing. Most of the time you see these questions, it's going to be on multiple choice. And I can guarantee you that answer I circled won't be one of them because it's not technically simplified. Which one will be? This one here. So all you got to know is this guy and this guy are the same thing. Okay. Because like I said, if it's a free response or if you're doing this on homework, I'll take this answer. This answer is great. I have no problem with that answer. But on multiple choice, they don't like negative roots or negative powers, I should say. So they most likely will have this one. Okay. Okay, so let's go to the next one. It has a power, but it's a fraction. We've talked about fraction powers, but this is not a fraction power, right? So what can I do to make this not a fraction? So what would it be? There you go. No more fraction. Same thing, I brought it up top. To bring it up top, you just change the sign of the power. So let's do our trick again. Let's do our power rule. Power rule says move the old exponent to the front times what was already there. Well, it was just a 1. Subtract 1 power. So I got to subtract 1 whole power. So if I subtract 1 whole power, that's going to be negative 5 power, right? Again, that answer is correct. I'd give you full credit for this for negative 4 times x to the negative 5. But if it's a multiple choice question, more than likely, they want you to move back down to x to the 5th. These are the same. They're both the same answer. But I'm just saying, one of them is going to probably be on a multiple choice, one of them won't. This guy won't be on A, B, C, D. And if you're looking for that guy, it won't be there. This is the guy that will be there. Okay? Okay. That's the power rule. That's the one we're going to use almost every single time. Okay? So constant function. So a constant function means just a number. So if f of x equals 5, didn't our rule say we need to bring the power down? What power does 5 have? 0. Yeah, it has x to the 0 power, right? Technically has x to the 0 power. So if I bring that to the front, what is it going to be every time? 0. So the derivative of a constant function is always 0. Derivative of pi, 0. Derivative of 1/3, 0. Derivative of a million, 0. Anything without a variable, the derivative is 0. Okay? Multiples. So this one I really don't use a lot because I just use the power rule. This one says you can find the derivative, like I can move the 5 to the front and then, but you don't need to do that because we can just use what we've done before, right? We multiply 7 times 5. Subtract 1. So you get 35x squared, x to the 6. The power rule is not bad, right? It's not bad. You guys have seen it. The hard part, or I don't want to say the hard part, but sometimes where it gets caught up is the before part. Making it so I can use the power rule, right? Look at B, 3B. 3B is kind of set up like 1C. How can I rewrite this without a fraction? So what can I do to rewrite this, make it without a fraction? So yeah, the first thing I can do is take 4/5 away. from x to the third. Right? Take them away, split them up. And then do what we did before. Once you do that, power rule's easy. You're like, oh, okay, I know what to do now. The hardest part about using the power rule is sometimes you have to kind of manipulate, change them a little bit so you can use the power rule, right? Over here, I couldn't use the power rule yet. Over here, I can. So let's use the power rule now. So move the -3 to the front, times 4/5, subtract 1 power, I get -4. Multiply the coefficients, I get -12/5, x to the -4. And then bring it back down, yeah. So I'd get -12 on top, 5x to the 4th on bottom since it was negative. Okay. Anytime you have a root, change it to a power. Anytime you have a fraction, change it to a power. Okay. Just like this. That's probably the hardest part about that, is being able to do that. Okay. Sum and difference rule is just, it's a lot hard. It looks a lot harder than it really is. All we're going to do is just find it. All it is we're just going to go one by one by one. We're going to do each term on its own. Okay, so the sum and difference rules on the bottom. Example, the next example's on the front, or the behind that. Okay, let's see. Okay, example number 3, 3a. Should be 4. The second 3a. Yeah, should be 4. The numbering's off for some reason. I don't know why. Oh, well. Okay. We're just going to go term by term. 4a has 1, 2, 3, 4 terms. So we're just going to do the power rule 4 times. We're going to move the 3 to the front, subtract a power. We're going to move the 2 to the front and multiply it with the 4 to become 8 and subtract a power. We're going to move the 1 power times -2 to make it -2. No more x because it would be x to the 0 power. The derivative of +7 is just 0. Done. That's the derivative. Again, something that would have taken us 15 minutes to do the hard with the long way, now it takes us 5 seconds. Okay. Okay, B. B's got some fractions now. Because what's the derivative of 7? The derivative of any constant is 0. So, I mean, I could have added, so you could put 0 plus 0 here, but it really doesn't affect anything. It's not wrong. It's not wrong. Okay. B. So now we got to change this to get rid of the fractions so that we can do the power rule. Okay. Well, let's change this. So let's rewrite this. So 3, let's see, times -2x to the -4. Oh, +4, sorry, +4. Because when I move it up, oh, sorry, no, it's -4. You know what, before we do that, let's simplify this. Because it's got parentheses, so let's simplify this. So -2 to the 4th is 16. So this would be 16x to the fourth.
You would still leave the 4.
What's that?
You would still leave the 4 after you multiply it with the -2.
Yeah, because everything on the inside gets a power. Yeah, so everything on the inside here gets a power. So -2 to the fourth is -2 times -2 times -2, which is positive 16, and then x to the fourth. So that would be 3/16 times x to the -4. The next one would be 1/2 times x. Yeah. So we'll finish maybe this one and we'll be done. Yeah, the new schedule. So we got about 12 minutes. And then the last one is just positive 1/4, just a constant. Okay. That's the hardest part. And what I just did there is not calculus. I haven't found a derivative yet. I just changed the way they look so that I can use the power rule. That's what I'm saying. That's the hardest part. It's not using the power rule. The power rule, I find students are really good at using the power rule, but it's just sometimes they use it when they're not supposed to, and sometimes this part here, the background stuff. Okay, so now I'm going to use the power rule. So I move the -4 to the front times 3/16. Take away a power, it's x to the -5. For -1/2 x, well, it's just one power. So I move that to the front, and it would just be -1/2. Yeah, and then 1/4 is just the constant. So that's the derivative of any constant is just 0. So we multiply. See, I can simplify this to make -1 and +4. So it's going to be -3x to the -5 minus 1/2. Clean it up a little bit. -3x to the 5th minus 1/2. And you were done. That's the derivative. Okay, so we're going to do example number 4. We'll be done.
How'd you get the -4?
-4. The power. This guy comes up here. The power rule says move the power to the front. Move the power to the front and multiply. So I got -4 there. Okay. Number 4 is exactly the same. The only difference is we have to find the equation of the tangent line. We've done this before. We did this yesterday, I think. We did a problem like this. So to find an equation, we need a slope and we need points or point. To get a slope, I'm going to use the derivative. So the derivative, let's see, the function's over here. F of x is right here. So it's going to be 12x squared minus 6. That's the derivative. To get the slope at 2, I got to plug in 2. Twelve times 4 minus 6, what is that? 48 minus 6, which is 42. That's the slope at 2. The slope at 2 is 42. Okay, so y minus y1 equals slope x minus x1. Well, 42 is the slope, so that's going to go there. Two is x, so that's going to go here. How do I get y? Yeah, so plug it in. Which one? F of x or f prime? F of x. So plug in 2 to the original, and you get y. So 4 times 8 minus 12 plus 5. Let's see. 32 minus 12 plus 5. 25. You were done. Find the derivative. Find the slope. So let me write this down. Let me write down the steps that I used. Last thing. Find derivative. So find f prime. Find slope of tangent line. Find the derivative. Find the slope of the tangent line. Use y minus y1 equals m x minus x1. And you're done. Yeah.
For the number, the example above.
Yeah.
Shouldn't it become negative 3/4 for the first x?
Oh, yeah, sorry. I totally missed that 4 on the bottom. Yeah, you're right. Negative 3/4. So that 4 should go down there. Yep. Thank you. Because there was a 4 on the bottom, red 4. I totally missed that. Yeah, you are right. So the power rule, like I said, we're going to use the power rule from now and probably until the end of the year. It's just such a often used thing to find derivatives. Anytime they ask you to find the derivatives, chances are you're going to use the power rule. At some level, you're going to use the power rule. Okay? So we'll start with example number 5 tomorrow. And then there's a couple more rules. There's a product rule and a quotient rule, but pretty much they're offshoots of the power rule. Okay, and then we'll be done. And that's it. Those are the rules. And then after that, there's one more rule called the chain rule, which we'll show you. And then that's it. That's all the rules. You'll be able to find the derivative of anything. Okay. Mm-hmm. Yeah. Some of the questions weren't matching? Let me see.